Hello friends, welcome to your only channel Times of Coding. Today in our series Scala Express, we will learn traits. This session will help you to understand Scala traits, how to write, where to make sense with classes, and few real-time tips as takeaways. In previous session, we have covered Scala class ladder or hierarchy you may call, and we have seen default parent classes and the subclasses of Scala. In this session, our focus will be on Scala traits, how to mix these traits with classes, and tips as takeaways. Traits encapsulates method and field definition, which can then be reused by mixing them into classes. So unlike classes, we can have n number of traits and we can mix in our classes definition. Now I'm defining one of the simplest trait definition here as animals. The keyword we need to use while defining trait is trait instead of classes, which we have seen earlier. In this trait, I'm keeping two member functions. One is our leg definition, and I'm not keeping any value with it. It is just a signature. So this leg will hold a value of int type, and then we are overriding one toString functions here. This toString function is coming from the anyRef class because by default, all of the reference type of classes and traits will inherit it from anyRef class, and anyRef class is the immediate subclass of any in Scala. So likewise we can override this function, and this was about how to define the trait. Now we will come how to extend. So extension of this trait will be possible from extend or with keyword that we will see in. So here I'm defining one class as elephant. In this elephant class I'm keeping animals with extend keyword. Since we have not defined legs function here, we need to override it and we need to keep it the definition. Now let's create an object of this class. So I'm creating one object as Appu of elephant class, and then I'm calling Appu.legs. So technically it should give us 4, which we have defined here. And then I'm calling out Appu also to call the toString method by default. So now Scala will compile and run these three statements, and it will give us val Appu elephant is equal to animals.toString. That animal.toString, it is coming from toString method, and then we are printing out Appu.legs, so it will give us 4 as defined, and then we are writing Appu.toString again, so this will get us animals.toString. So just like classes, in fact we can declare type of traits also while defining some object or maybe while writing our business logic. So here I'm keeping val Appu, and this Appu is type of animal. Animal is a trait. And then I'm keeping one new elephant object in this variable reference. As a Scala programmer, you can mix many traits, but it is not like multiple inheritance that we will see in my further session in detail. But for now, we can extend multiple traits, but it is not a multiple inheritance. For time being, we need to remember like this only. And how to mix more than one trait within a class, that we will see in this example. So to do that, first we need to define few more traits. So I'm defining here the birth pattern as baby, and then I'm defining trait wild. With this class of elephant, I'm extending animals, and with keywords help, I'm extending birth pattern as baby and wild. So here also we need to keep override definition as 4. After all, it is a rewriting of elephant class. So that's how we can inherit multiple traits in our class. Unlike classes, you should not have any parameter with your constructor. So here I will give you one example. While defining class, you can have parameters in its primary constructor, but at the time of traits, we suppose not to have any constructor parameters here. If you define like me as a beginner programmer, you will also get trait may not have parameter compile time error. There could be several ways to write a trait, and I will give you few traits type definition as one-liner. While defining trait, you can keep your trait as thin as possible. Thin traits means it will have some limited functions, could be abstracted. So when you define your traits thin, you may go with multiple traits. Next type is rich type. So when we define a rich trait, Basically, it covers all the function for that particular business feature, and its even edge cases also it covers in its definition. One of the advantage to define traits like a rich trait, in classes you may not be having any boilerplate code if the expectation to have the reusable code in that particular module. Now next trait type is ordered trait. Generally these type of traits are just have one functions, and this is for transactional purpose or this is for some standard functionality purpose. So let me give you again, traits in Scala do not support multiple inheritance by any ways, and the reason because if you trace their super call and multiple inheritance, it will get confused. So that retracement of super call will not be retraceable for compiler or for interpreter. That's the reason that confusion we have avoided in Scala. But if you see here, we are mixing multiple traits in one class. So what is that? So there, how we call it in Scala is we are mixing traits into classes on basis of linearization. Now when I say linearization, your super call will be traceable and it will be traceable in certain hierarchy which we will discuss in later session in detail. When first time I got to know about traits and mixins, even I got confused how to use it, where to use it, but with time, when you write code and when you take decisions where to write trait and how to mixins with your classes, you will be good with time and you will make a good decisions with practice. Practice is the only way to grip on this subject. The more you write code in traits and classes and the more you take decisions where to write reusable code and where not to write traits, where to write classes, where to write abstract classes, you will be good with time. Now, few takeaways I can give right away. If the behavior will not be reused, then we need to write a concrete class. Let me repeat it again. If the behavior or feature which we are writing in our function or classes or traits, if it is not a reusable behavior, we should always keep as a concrete class. Point number 2, if we are using that feature which we are defining today, if we are reusing that code, we must give consideration to traits or abstract classes on basis of our need. Point number 3, if you wanted to inherit some of the functionality or features or some methods, let's say you just override few functions from Java standard library, in that case we must keep as an abstract class. And point number 4, if you wanted to have some efficiency while computing your logic, so let's say the class which you are writing, the features you are writing, it has direct impact on the computation engine or some computation framework. In that case, we should always go with the classes. Classes will give you slightly better performance than traits or any another thing in a Scala. So in theory, we have covered today content. Now we will do the practical of elephant class example. So first, after opening IntelliJ, first we will create one package called traits today. And in that traits, I will define animals. So here you need to choose trait and then we will name it as animals. And now we will keep one function as legs, and this legs will have integer type, and then we were overriding toString method, and here we will keep customize debug message as animals trait. After defining this toString, we will write another class where we will extend this trait. So this class I will write as elephant, and elephant will extend animals, and since we do not have defined legs definition, we will override, and here I will keep it as 4. So that's how we extend trait with our classes. Now after this we have seen how to create an object of this class. So I will create another Scala class. Here I will pick object and here I will choose animals run. And in this run, first thing we need to create a main method, and inside the main method we need to create one object And since elephant is not having any constructor parameter, I'll keep it as it is. And then we will print it, this object, as elephant number of legs. So now I will get an option to run, and it gave us 4 as expected. Now we have overridden toString function also, which will get implicit call if we just print Apu here. I'm running again. Okay, animals trait we have received as expected. Now after this we have discussed if we can give it a type to this object. So I will keep it animals type, and since elephant and animals trait and elephant class is compatible, we will not be having any issue. And this underline green is a typo error which IDE thinking that we have written wrong spelling. Okay, so I'll do more action and I'll save Apu to project level dictionary. So this green underline will go away. Again I will run it and it is fine with the Scala. Now next thing we have discussed, where we have created multiple traits and we have extended those traits with elephant class. So first we need to define them. I'm defining trait while, and then trait birth pattern as babies. Now the same we will use with keyword birth pattern as babies. Okay, so you see Scala compiler is not having any issue, and when we run this object now, we are able to run successfully. Now after this, we have discussed if we can add parameter to our traits. So here I will add one parameter into that elephant class, and I'll make it as boolean type, and the same I will try to add in wild also. So you see here we are having red underline, which means compile time error from this IDE, and when I run animals run, it will show the compile time error called traits or objects may not have parameter as expected. So we cannot define parameter with traits. So with this example, we have covered today's content. I hope you liked today's session. You can like, subscribe, comment, and share with your friends and colleagues to share this knowledge. Thank you. Have a good day.